Hello guys, welcome back. Today we again have some very good questions from the Allen score test series. So here is our first question for today. What I would like to recommend once again is these are very good questions, so please pause the video and try it out for yourself and then only look at the solution. So we'll wait for a few seconds. Okay, I'm starting off with the first question. So basically we have cot x equal to given some a0 by x plus a1x plus a2x cube. And we have to find out which of the following are correct. We have to ascertain basically the values of a0 and a1. So now from this it's impossible to ascertain anything. So what I will do is we actually know the expansion for tan x, right? It's called, I guess, Maclaurin or Taylor's expansion. I will write it down in the comments. I don't remember the exact name. So first we'll write down the cot x. Cot x is basically a0 by x plus a1x plus a2 x cube plus ak x bar 2k minus 1, and this goes till infinity. So now there could be actually two reasons why I selected tan. First is we have cot, so basically if we write tan we can multiply and get the LHS as 1. And another reason is that tan also has like similar type of the powers of x. Only this, I guess the first place in tan is plus x power 1, but that doesn't matter. And these are all odd powers also, so I guess tan will be perfectly fitting for this. So let's write down tan x. Now if you guys don't know the expansion for tan x, so please do by heart this like sine and cos, because this is very important. This is x plus x cube by 3 plus 2x power 5 by 15, and this also goes up till infinity. So now what I will do is I will plain simple multiply these two equations. This means multiply. So 1 is equivalent to x plus x cube by 3 plus 2x power 5 by 15 plus this is till infinity, and here we have a0 by x plus a1x plus a2x cube again till infinity. So we will do the normal multiplication. We will try to multiply one by one the terms. So if we multiply x, the first part comes out to be a0 plus a1x square plus a2x power 4 till infinity. Again, this will become x cube by 3. If we multiply, this will become a0 by 3x square plus a1 by 3x power 4 dot 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 till infinity. Next, this will become 2x power 4 by 15. Although I guess we will not need till here, but I am still writing. This is a0 plus this will become 2x power 6 by 15 a1 plus this is also till infinity, and this whole thing also goes till infinity. I will change the page. So now what we do is we try to segregate the terms. Okay, first we will segregate the constant terms. So basically we have only one constant term, which is a0, and after that we take x squared common and segregate. This becomes a1 plus a0 by 3, and this again goes till infinity. I guess we will not need the higher powers. This part is sufficient enough to calculate what we need. So basically if we compare, a0 will be 1 because it's the only constant term, and from here, because there is no x squared term on the LHS, so a1 plus a0 by 3 is 0. So basically a1 will be minus a0 by 3, which is minus 1 by 3. So a0, and we have the values of a0 and a1, and I guess that was required in the question. So now we will go on to the options. So in our options we have capital A as a0 1, which is absolutely correct. In option number B we have a0 is 3 times mod of a1, so mod of a1 is 1 by 3 into 3 is again 1, which is correct. In option C we have a0 plus a1 is 4 by 3. No, this is wrong, because 1 minus 1 by 3 is 2 by 3. C is wrong. And in case of D, a0 plus 9 a1 square. A1 square is 1 by 9 into 9 is 1 plus a0 is again 1. So this is 2. So basically this is also correct. So our correct options for this question is A, B and D. I hope you guys understood. Now we will proceed to the next question. So here's our next question. Basically this is a comprehension type question. So what I will do is I will solve out the part 1 for you guys, and as you can see, if you read part 1 and part 2, there is only one fundamental difference. In part 1 we have this difference greater than 0, and part 2 we have less than 0. Rest of it everything is same. So basically if you understand how to do part 1, then part 2 is basically really simple. It's just some values will change. So what I will do is I will solve out part 1 for you guys, for you to understand, and I will leave out part 2 with the answer. If you guys can't do it, you can tell me in the comment section. I will post the solution, and I guess it will be pretty easy. I will also leave the answer of the part 2 for you guys to try out so that you can gather up some confidence. So basically if we see in this particular comprehension, we have a function f of x, which is, it is given that it is continuous and also twice differentiable, and f dash of c1 is equal to f dash of c2, which is equal to 0. So this is the information we have. We also have some other things like f of c1 is 5, f of c2 is 0, and c1 is less than c2. And we also have a very important, this is actually the most important in this whole question, f double dash c1 dot f double dash c2 is less than 0. So now if these two are like their product is less than 0, which basically means that they will be of opposite sign, right? So I guess because c1 is less than c2 and their product is less than 0, that is they are of opposite sign. So from here we can conclude that f double dash c1 will be actually greater than f double dash of c2. I hope this is pretty obvious from here and here. So, and also one thing, f double dash, I guess c1 will be greater than 0 and f double dash c2 will be greater than 0. I've actually started solving part 1, I didn't write. Basically because this thing was given, and okay, did I say, I guess I said that we ascertained this. No, I'm sorry. This part was given, okay. I'm sorry for the mistake. So if we find out f double dash c1 will be greater than 0 and this thing is less than 0. This thing, that is actually what changes in part 2, okay. Then part 2 we have f double dash c1 less than f double dash c2. So subsequently these signs will change and you will understand soon what to do. So basically if we write out in terms of language, then c1, here c1 will be our local minima. Pretty obvious. And c2 here will be our local maxima. So now we have to find out the minimum number of solutions of f dash x equal to 0 in between this interval of c1 minus 1 to c2 plus 1. This is also used in the second question. So if you guys watch this carefully, you will be able to do the second question, I guess, pretty easily. So yeah, now I guess if we observe carefully, because f double dash c1 and f double dash c, these are local minima and local maxima. So already we have two roots actually for f dash, right? These are c1 and c2. Pretty obvious from the first part itself. Now we will have, I guess, other roots also. I will show you how. So basically if you notice the question, fx is twice differentiable function wherever it is continuous. That's pretty obvious. If we have a continuous function, then obviously it is differentiable, and if it is not continuous, there is no question of it being differentiable. But f of x, this particular thing, is actually continuous in between c1 and c2 only, and our the interval in which we have to solve is basically c1 minus 1 and c2 plus 1, which means that at are x equal to c1 minus 1 and x equal to c2 plus 1, here at these 2 points this function will actually become discontinuous, right? Pretty obvious. So if this function becomes discontinuous here, either it will be due to vanishing or another reason could be a sharp corner. So basically what I guess is c1 minus 1 and c2 plus 1 are also roots, not of fx, please note, for f dash x, right? If you guys can't understand why, basically for f of x, these two functions, it is discontinuous at these two functions. Say if I take an example of modulus x. So if you differentiate modulus x, it will come out to be as 1 and minus 1, right? Like x greater than 0 it is 1 and at x less than 0 it is minus 1. So at two particular points it has two different solutions. F dash x has two different solutions at two particular points. They are different, I guess obviously different. So some sort of thing happens here also. If this is discontinuous at these 2 points, like f of x is discontinuous at these 2 points, then f dash x will obviously have roots at these 2 points. So I guess no more roots, and so our work is done. Basically we have to find out minimum number of solutions, and this is what we can ascertain from the given conditions. So our roots are basically c1, c2, c1 minus 1 and c2 plus 1, these 4. So 4 is the first part's answer, and now I will tell you the answer to the second part. So the answer to the second part will come out to be as 2. Okay, this is nothing basically. I will also tell you guys if you want it, as this is reversed, f double dash c1 is less than f double dash c2. Basically these two things will reverse. F double dash c1 will be less than 0 and f double dash c2 will be greater than 0, and after that c1 and c2 will obviously be your local minima and local maxima. So these two are obviously roots, and after that this part I guess you can do, because their signs are reversed, you will get a lot of changes actually, and that is exactly the same as we did in the first part, only the answer will come out to be different because their signs have reversed. I guess this is pretty clear. So, and if you guys can't solve this for part 2, please tell me, I will post the solution. Okay, so no problems, you can tell me out in the comment section. I left this so that you can build up your confidence. So now I will proceed to the next question. Here's our next question. This is also a comprehension type question and a very interesting question. And this will also go a bit long, okay? I'm telling you. Because we have to not only solve this calculus like area and find the part value of part 5, but after part 5 and part 6, we also have a probability question. So we have to solve that also. So basically they have just lengthened the question as much as they can. So I will pause. You can pause the video actually and try out. I will start off now. So basically we have two functions, f of x given as cos inverse of cos x whole square and g of x given as cos inverse of cos x. So here are our two functions. So basically what we have to do is we have to like draw the graph, because otherwise it's impossible to understand how to find out the area. You have to draw the graph for these two. Now cos inverse cos x graph is something that you guys know, I guess. This is a very standard graph in inverse trigonometric functions. I will draw it out for you guys once for you to recall. So I will try to draw the graph of cos inverse of cos x. This is our y-axis. I will draw a small part, okay, just for you guys to recall. This is somewhat the graph. I hope you guys remember that cos inverse cos x will never go below the x-axis. It always stays above. Something like this. So this is 0. This point is pi. This is, I guess, your 2 pi. This is 3 pi and so on. So now we can write the equations of, these are all straight lines, so this is y equal to x. This thing will become, because it's going down, so obtuse angle, negative slope, so y equal to x minus 2 pi. This will be positive slope, so y equals to, this one I guess will become y equals to 2 pi minus x. Okay, just a minute. Okay, sorry, I actually reversed this thing. This one will be 2 pi minus x, I'm sorry. And this is x minus 2 pi. So this is somewhat the graph of cos inverse cos x. Or what you can do is, if you also don't remember the graph, you can like draw the interval for this, because this shape I hope you can remember, like it's like a straight line going up down, zigzag. You can remember the shape, but if you don't know, remember the intervals of the points, you can actually like put a bracket like this and graph out, like point out the different values, and after that you can do it pretty easily. So now we know g of x, but for f of x we don't know anything. So basically I will try to do that. So our g of x, I'm sorry, f of x, which is basically cos inverse of cos x squared, this thing will be equal to x squared. From here I'm referencing when x is belonging to 0 to pi, and it will be your 2 pi minus x whole square when x is belonging from, I guess, pi to 2 pi, and so on. We will not actually need more intervals. We will need only up till 2 pi. So now if we observe this, let's say we consider a particular point. We have to find out an intersection, right? So if we find out an intersection for x equal to x square, so basically you can write it as x square minus x equal to 0. So this is x into x minus 1 equal to 0. So at x equal to 0 and 1. Now at x equal to 0 and 1, so basically I'm drawing it here. This is 3.14, so 1 is somewhere here, right? So the graph will intersect like this, and maybe the shape is not so good. Intersect like this and go up. Now I can like draw the graph. We have an idea, right? How the graph will look. Basically this idea was to demonstrate that the graph of g of x will be little at a lower height than the graph of f of x. I will show you guys how. I will draw the graph. So after a lot of efforts, here is our graph. Basically this part, I'm tracing it, you can see this particular part, these are curves. Okay, if this looks like a straight line, I'm sorry, but these are actually curves. So this part is for your f of x, and this is, I guess, pretty obvious, this is g of x. Now if we look at the intersections, one we have already found, this thing is 1. And if you try to find out this particular part, for that you have to solve basically 2 pi minus x whole square. I'm not solving it. Basically if you actually observe this equation and compare with this, basically after cancelling you will get 2 pi minus 1. I don't know if you guys can understand, otherwise you can solve it also, but I did it mentally. And this point here, this point is here intersecting, this is 2 pi, and here in the middle we have pi. And if you want to find out this point, maybe this point is basically our pi comma pi. So this is somewhat the graph. So we have to, I guess, find out the area. Now to find out the area we need this part, and also this part. So I will write down the final equation so that you can understand better. Basically this is 4 times, I will say why I took 4. This is your 0, this is integral 0 to 1, basically upper curve, so cos inverse cos x minus of cos inverse cos x whole squared. So now in this part you will see this will become, this is x, the cos inverse cos x is x, and cos inverse cos of x whole squared is x squared. So this is x minus x squared dx. And for the next part from integral 1 to pi, this becomes x square minus x dx. So basically the reason why I took 4 is because we have to calculate all these. Okay, I will calculate this out for you guys. So I basically forgot to tell you an important thing. I guess you guys might have noticed it in the question. We had to calculate this in between x equal to plus minus 2 pi, okay? So if you like draw this part, this will be exactly mirror image of this. No difference. This is symmetric. So now like you guys from here, I guess I gave a wrong explanation. You guys might know that this is 2 from here, but if we take it on the minus 2 pi side, there are basically 4 parts. For this 4 parts and for this 4 parts. For this particular part, we will have this and this from here symmetric, and similarly there will be these two parts again, so 4, and this for this particular integral, and again there are two parts. That is why I have taken 4 to take x plus equal to plus minus 2 pi again. Okay, I'm sorry. So now we will calculate this. This is x squared by 2 minus x cubed by 3, which is 1 to 0, plus x cubed by 3 minus x squared by 2 from pi to 1. So now if we put the limits, we get half minus 1 by 3, rest of it this becomes a 0, and for this we have pi cubed by 3 minus pi squared by 2, and if we do a minus, this will be minus 1 by 3 plus half. So basically half minus 1 by 3 is 1 by 6, and this is also half minus 1 by 3, so 1 by 6 into 2, which is 1 by 3, plus pi cubed by 3 minus pi square by 2. I will change the page. So if we manipulate this a little, I'm writing the result. This is 4 times pi cube plus 1, and this will be minus 6 pi squared by 3. This will be your final result for the required area. And so I guess this was given to be something of the sort a times pi cube plus 1 plus b pi square by 3, right? Okay, not plus, minus b pi square. So from comparing, we have a equals to 4, b equals to 6, and c equal to 3. Here's our final set of results. Now we are ready to move on to the final questions. So for question number 5, we have to find 1 by 12 times a plus b by c. So this will basically become 1 by 12 times 4 plus 6 by 3, which is basically 6 by 12. So our answer for this will be 0.5 for the part 1 or question number 5. And now in question number 6, we have a permutations combinations question for which we had to find, probability question for which we had to find out a plus b plus c, which is 13. So let's read the question once. So here's the 6th question. Please note here are a plus b plus c is 13. So I'm reading it as 13. So 3 dice are thrown simultaneously, and p is the probability that sum of numbers appearing on each of the 3 dice is divisible by 13. So we have to find out the value of 36p. So basically we have to make cases for this. So we will do that and solve this question. So we have 3 dice. So basically our sample space will have a size of 216. This is your n of s. This is s, okay. I'm writing it in a better way. This is n of s. Yeah. So now we have to make cases. So if you observe from this particular thing, our 3 dice thing, our minimum sum possible will be 3 because it's 1 plus 1 plus 1. And maximum sum possible will be 6 plus 6 plus 6, which is 18. Just for a reference, this is nothing important. So now if we try to build our cases, I guess you can do it as you want, but the first case coming to my mind is 1 comma 6 comma 6. Another one can be, if we, I guess all it's included here, so another can be 2 5 6, 5 plus 2 7 plus 6 13. The next one can be 3 4 6 also. We can have 3 5 5 as well, 10 plus 3 13. And we can have 4 4 5 as well, 4 plus 4 8 plus 5. And I guess if we check out properly, I don't think any more cases are possible. I will, like, even if we add 4 plus 2, no, I guess no more cases are possible, because 1 2 3 4 5 6, yeah, these are the cases possible. No more cases are possible. So now we will find out the number of cases. So basically 166, so 3 factorial by 2 factorial, which is 3. This is your 3 factorial, which is 6. This is again 3 factorial, which is 6. This is again 3 factorial by 2 factorial, 3. This is yet again 3 factorial by 2 factorial, which is 3. So basically, if we sum this up, this is 6 2s are 12 and 3 3s are 9, so 21. So our probability for this particular thing is 21 by 216. And if we cancel this, say using, I guess, 3, so this will come out to be 3 7s are 21 and 372. So 7 by 72. So I guess we have to find out the value of 36p, right? 36p. So 36 into 7 by 72, this is 36 2s are 72. So 7 by 2, our final answer will be 3.5 for this question, and this is correct. So this was a very good question. They had mixed probability and areas, and the graph part was something you can take a learning from. It was a very good graph. I hope you have tried this question yourself, because if you haven't and seen the solution, then you missed something really good. So I will proceed on to the next question. So here is our next question, and I guess this will be the final question for our this video. So basically this question might look simple in the first glance, but this is a very bomb question on complex numbers. Okay, you need very in-depth knowledge of complex numbers and of every topic to solve this, because we will use everything. So basically the main thing that you require here is knowledge about nth roots of unity. Although I don't know, I have done using nth roots of unity, although I don't know if there are other methods possible. I will try to explore that as well, because this is a very good question. So basically we have to now find out the number of roots omega of the equation omega power 2025 equal to 1, such that it satisfies this condition. So basically we have omega power 2025 equal to 1. So now it's pretty obvious that there will be 2025 roots, right? And the condition given to us is mod omega plus 1 is greater than equal to root under 2 plus root 2. So now to solve this, we have to bring omega in a form such that we can proceed and find out the values. So what I will do is, like 2025 roots, okay, I said one wrong thing, I guess. 2025 is total possible. Number of roots we have to find. That is actually what is given. I'm sorry. So what we will do is, we know omega k. This is basically your Euler's form, or the form of nth roots of unity. This is e power I into 2 pi k by n. I hope you know that. Please, if you guys couldn't do this after pausing and still haven't done, then please pause and try it. Otherwise, look at the solution carefully, because this is a very good question. Okay. So this is cos of 2 pi k by n plus I sine 2 pi k by n. Now please note, I am this here, n is actually 2025. I will substitute it at the end because I don't want to make it clumsy. So what we were supposed to find here is mod omega plus 1, or rather we can say mod omega k plus 1. So this is your, we take the real parts in one bracket, 1 plus cos of 2 pi k by n plus I sine 2 pi k by n, this mod. And now we will just, to find the mod, we will square this and this up. So basically this will become 1 plus cos 2 pi k by n squared plus sine squared 2 pi k by n. So now if we open this square, this will become 1 plus, I guess, 2 cos 2 pi k by n plus cos squared 2 pi k by n and sine squared 2 pi k by n. So basically we have 1. So this becomes 2 plus 2. So 2 times 1 plus cos 2 pi k by n. Now we can write this as, it's pretty obvious, 1 plus cos 2 theta is 2 cos square theta. Or I guess 2 is already present. Okay, so this will become cos square pi k by n. Yeah. So we finally have our mod omega k plus 1 as 2 cos square pi k by n. So I will change the page. So guys, what I did was I made a small mistake. Basically, in this particular part, we are actually squaring the mod. Okay, I didn't mention the root. This is mod of omega k, I guess plus 1 is here, plus 1 squared, and this is also 2 to the 4. 1 plus cos 2 theta is 2 cos squared theta. So basically after this you take omega k plus 1 to be 2 cos of pi k by n, and you also put a mod here. Yeah, now it's correct. I'm sorry for the inconvenience. So now I guess we are ready to put this value into the equation that we have. I will do it. So basically what I will do is I will square both sides up, because in the RHS we had root under of 2 plus root 2. So better to square it. So this becomes 4 cos square pi k by n greater than or equal to 2 plus root 2. So our cos square pi k by n is greater than or equal to 2 plus root 2 by 4. Now this is an important value which you should remember. I guess you guys should remember this. Cos of pi by 8 is root under of 2 plus root 2 by 4. Many people also write the 4 outside, but I am writing it inside. So basically this thing is the cos square pi by 8, right? So if I take mods on both sides, mod of cos pi k by n will be greater than or equal to mod of cos pi by 8. So now we can put n equals to 2025, and now pi k by 2025 will, I guess, somewhere lie in between 0 to pi only, so the mods will open as positive. But here we have the mod, and so this can be either pi by 8, like when we compare the angles, because cos of both sides are opening with positive basically, but cos of pi by 8 is also equal to your cos of pi minus pi by 8. This mod can open with plus or minus. I hope you can understand. Like either pi by 8 somewhere here, or it can be also pi minus pi by 8. So basically now this thing is 0 to pi, so we don't have to worry about the sign. This is positive obviously. So first, if we compare pi k by 2025, we will actually get two conditions from where we will get the final answer, the total number of solutions. So pi k by 2025 will be greater than or equals to, I guess, pi by 8. Just a minute. Okay, there was a mistake. This is pi k by 2025. By mistake, I wrote this is greater than equal to. This thing is actually less than equal to. Okay. I hope you can understand why. Because pi k by 2025 is lying between 0 to pi, and this can open with two different signs. So this will basically lie between less than equal to pi by 8, and here we can write less than equal to pi minus pi by 8 like this. If you want, you can write it in one step in one go. Like pi minus pi by 8 less than equal to pi k by 2025 less than equal to pi by 8, but we will get two different sets of solutions, so I am writing it separately. Okay. So we write or pi k by 2025 is greater than or equal to pi minus pi by 8. So basically from here pi and pi will obviously get cancelled in both. This is 7 pi by 8. Here we cancel the pi. So k will be here less than equals to 2025 by 8. And here k will be greater than equal to 7 into 2025 by 8. Now if we try to ascertain the values, I have already calculated the values, so I am writing that this thing is somewhere around 253.1, and this is approximately, it's a big value, it is 1771.125. So basically now if we try to write out the number of solutions from here, we have k less than equal to, k is obviously integer, it can't be a decimal number, so k here will be from 0, 1, 2 up till 253. So basically here we have a total of I guess 254 solutions. And for this part, please be careful. This is greater than or equal to 1771.125. We can't include 1771. We have to include from 1772 because they can be only integers. And this will be up till 2024 basically, right? Now from here some people might have a confusion, why didn't I take 2025? Okay, so basically if we see omega power 2025 equal to 1 was our original equation, for which we had that e power I 2 pi k by n or e power I 2 pi k by 2025. They were the solutions and we wrote Euler's form and solved everything. So basically if we take e power I 2 pi k by n, 2025 solutions are when in that particular Euler's expression k is basically varying from 0 to 2024. That is 2025 in total, right? So maximum value here possible is 2024. Here is where most of you guys might make a mistake, because the answer is something like, the answer is actually 507, we will see soon. But some people can take it as maybe 508 or 506. Either they will make a mistake here, they will not take 0, or they will take 2025 and add 1 extra to get 508. So basically if you do that, you will solve the entire question correctly and do mistake in this part and ruin your marks. So please be careful. So now if we calculate the number of terms here, this is 2024 minus 1772 and plus 1. I hope you can understand. So basically this, I guess I will calculate this once. So this comes out to be our 253. So now our question is done. So basically the number of solutions in total for the given equation to satisfy will be 254 plus 253. This will be 507. This is our final answer. So please be careful with this part, guys, and also with the inequalities, like how I explained, this is less than equal to and greater than equal to. Basically, if you want to write this in a simpler way, I will do that also. You can write this like this: 7 pi by 8 less than equal to pi k by 2025 and less than equal to pi by 8. In case you guys face a problem in understanding this, you can write it like this also. You will get the same result actually. So this is it. This was a very, very good question on complex numbers, a really bomb question on complex numbers. So I guess this will be the last question for today. And I hope you enjoyed the video, and I will try to bring out more such questions in my upcoming videos. So do like, share and subscribe, because that's what encourages me. And if you have any doubts or recommendations regarding what I should do in my next videos, you can drop it down in the comment section. So that's it for today, guys. Thanks for watching.